Hi, my name is Hannes Harter and I'm a research assistant at the Technical University of Munich. I'm now going to explain to you the Lifecycle Assessment module of the EERAdata project. The inputs for the Lifecycle Assessment module are, besides others, the building materials, the building cubature, and the results coming from the energy demand and heating load module. As building materials, different main construction and insulation materials can be considered. Also, the reference service lives of these materials are an input which define the amount of replacements of the materials along the building's life cycle. The building cubature and the building size, so its length, width and height, are used to calculate the surface areas of the building components. The final energy demand as output of the energy demand and heating load module serves as input for the respective emission calculations. All these input parameters and their value definitions are loaded into the Lifecycle Assessment module. A module calculates the energy demands and emissions regarding the production, use and end-of-life stage of the building or the building materials and technical building services or components according to international standards. Therefore, the building construction and insulation materials as well as the technical building services components are dimensioned in a previous step. The results of the calculations are the primary energy from non-renewable and renewable resources and the global warming potential resulting from all mentioned life cycle stages. These results again serve as input for other assessment modules. The savings in global warming potential comparing the status quo with the renovation serves as input for the socioeconomic assessment module. The results are also reported in the EERAdata reporting sheets, which I will show on the following slides. The life cycle of the building considers of the production, use, and end-of-life stage. The life cycle assessment module calculates the energy demands and emissions resulting from all of these life cycle stages. As said before, we are considering the components and materials of the building construction as well as of the technical building services components. Structural building components consists of the main construction material as well as of the main insulation material in different variations, ranging from sustainable to less sustainable solutions. For the technical building services components, heat generators, heat storage tanks, distribution and transfer systems are considered. On the left side of this slide, you can see all results coming from the Lifecycle Assessment module presented in the EERAdata reporting sheet. The reporting sheet allows a quick and efficient overview over all achieved results. The benefit of the Lifecycle Assessment module is that it allows the lifecycle-based assessment of the energetic and ecological performance of a building in its status quo, so before renovation and after applying different energy efficiency measures in the scope of renovation. I will now switch to our decision support tool and show you how to select the Lifecycle Assessment module for a building assessment, and I will also show you the calculation results presented directly in the decision support tool after applying the calculations. After you defined your project and assigned different buildings to this project, which is explained in the video to the general functions of the decision support tool, you can now choose the calculation module you want to apply in your project on your selected buildings. In my case, I'm choosing the Lifecycle Assessment or LCA calculation module. After assigning the module to the project, we can go on and define different renovation measures as options. The status quo of the building is calculated in any case, so what we have to do here is to define renovation measures if we want to apply them to our buildings. In the first step, we click the Create button to create a renovation measure. First of all, we have to give this renovation measure a name and then we click Save. When selecting the Edit button of the defined renovation measure, we can click the Measure button and search for predefined renovation measures. The predefined renovation measures are also explained in a separate video concerning specifically this topic. We are choosing a very simple example and adding insulation to the exterior wall regarding an ambition renovation standard. In the next step, we are clicking on the results header and press the Run Calculation button. The before mentioned results are showing up in the table you can see here. Since the Lifecycle Assessment module partly builds up on results from the Energy Demand and Heating Load module, the energy demand and heating load calculation is performed as part of the Lifecycle Assessment module, and the corresponding results are presented here. The main Lifecycle Assessment results are the primary energy demand from non-renewable and renewable resources and the global warming potential for space heating and domestic hot water. Additionally, the primary energy from non-renewable and renewable resources and the global warming potential for the production, use and end-of-life stage of the building, construction materials, and the technical building services components are presented as sums. You can compare the before renovation state, so the status quo, with the status after renovation. You can see that the renovation measure decreases the primary energy demand from non-renewable and renewable resources, and therefore also the global warming potential in the operational phase. Try the calculations out by yourself and meet me in Gathertown to discuss the Lifecycle Assessment Calculation module. I'm looking forward to seeing you there, and I'm also happy to answer your questions after the conference. Thank you.